Without warning, you hear a loud bam and your vehicle lurches until everything slows down, enough to regain a bit of control so you can guide your vehicle onto the shoulder. Soon you realize that those horrific moments you just experienced were caused by a flat tire. 30 or 40 years ago, when I learned to drive, the hazard of a tire blowout while driving was something we actually thought about. But it's not really a big concern anymore. Tire quality and tire pressure monitoring systems have fundamentally changed our relationship with the car tire. Today, there are hundreds of sensors that affect your vehicle every day. This same trend is affecting the safety and productivity of energy and mining vehicles as well. In this video, we'll explore 4 major vehicle sensor innovations that are common in mine trucks and other industrial vehicles. Let's go. Now, we just went through how tire pressure monitoring changed car use. Heavy-duty industrial vehicles like mining equipment have improved as well. Bridgestone, the tire manufacturer, tells us that their monitoring system lengthens the life of large tires by decreasing tread wear and minimizing damage when the tire hits something unusual. As with cars, monitoring tires makes equipment safer for operators because there's less tire emergencies. Mine managers also love it because they see a decrease in fuel usage when the target tire pressure is maintained. Okay, that's pressure monitoring. So how does all of this work? It's actually pretty simple. A pressure sensor is attached to a valve stem in the tire, and this sensor then sends the pressure data to a wireless receiver that then transmits the data to the cloud for analysis and reporting. A warning email or a text is sent when there's a situation that needs attention. But tires isn't the only thing that we can monitor. A very simple sensor system is also being used in other parts of heavy equipment. So let's look at a few other examples. What if we could identify road maintenance problems? At some point you may have hit a pothole and wondered if your front end was going to be left behind. This is also a problem in mine sites and construction sites. The condition of these roads changes so often that it's hard to stay on top of all the changes. What if the haul trucks that drive these roads could identify where there's issues in the road? Last year, a team of researchers in Korea figured out how to use common sensors on a haul truck to not only identify where the road needs repair, but also identify locations where dust levels are too high and roads need watering. The location and road condition data was transmitted wirelessly back to the mine network and then to the cloud for analysis. This research is pretty cool, but it's definitely not unique. Many researchers and engineering teams have made this even more practical. They use a group of built-in sensors that come with most new haul trucks to do the same thing. Some software uses data from the suspension systems to identify locations where the suspension absorbs more shock. We'll see more examples of the suspension system measurements a little bit later. An easier and more reliable measurement may even be to use the onboard 3-axis accelerometer. I've put some of the research links in the show notes below. So how does this road maintenance system work? This is where the data science comes in. Whether it's suspension data or accelerometer data, the data scientists are able to identify signatures in the data that identify different types of road conditions. The data signatures are then loaded into the monitoring software to notify maintenance personnel when certain road conditions are encountered by a truck. When the alert comes in, the maintenance crews can be dispatched. Knowing the type of road condition that they're dealing with and its location before they even go out is super valuable. Okay, that was a little bit complex. Let's look at a really simple example called predictive maintenance. This data signature thing that we just talked about, it applies to a bunch of other scenarios. A super simple one is a predictive maintenance sensor on a motor, a pump, or a bearing. You can get vibration sensors now that just stick on the side of rotating equipment with a magnet. The battery-powered sensor then sends the vibration data to a monitoring system. This data is used to predict failure. When a bearing starts to wear out, it starts to vibrate in a more dramatic way. And when the vibrations grow past a certain threshold, it's time to repair the bearing proactively so you don't have costly, unplanned emergency downtime. All right, that was a simple one. Now let's go back to one more complex one before we wrap this thing up. Haul trucks do a lot of different jobs in construction and mining. One of the challenges is knowing how many loads any particular truck has hauled and where each was picked up and delivered and how much was in that truck. What if we could identify each of these trips and automatically generate real-time activity logs for dispatchers and site managers to optimize operations? How would that work given what we've already learned about other sensor scenarios? First of all, we'd need data from sensors. Maybe we can use the sensors that are built into the haul truck, maybe something different. Then we'll study that data to find signatures to identify different haul truck events and how much is in the truck. What events do we need to track to get that? It boils down to a few key events. And then there's some other information like load that we could calculate as well. First, we need location data to tag each event. In above ground scenarios, we can use GPS and inertial data similar to the smartphone that you have in your pocket. Fortunately, that's already quite common in most haul trucks. Underground is a bit more complicated because GPS doesn't really work. I'll save you the underground location tracking information and methods for another video. Secondly, we need a sensor that can tell whether the truck is loaded or not. This will help to pinpoint where the truck gets loaded and where it gets unloaded. There are other sensors like box position that could tell us when a load gets dumped, but it wouldn't be able to tell us when it gets filled. If we can solve for the load, that's the most useful. So how do we measure the load of a truck? There are a few built-in sensors that can help us. Let's take a look at one specific sensor type. In 2015, Joshua Henze from the University of Alberta proposed that he could calculate the load distribution in a haul truck using strut pressure data. He focuses on the strut pressure for each of the 4 sets of tires: the front, the back, left, and right. By combining the strut measurements from all 4 corners of the truck, he is able to model the shape and size of the load in the truck at any point in time. Here's the result of his tests in a real mining environment. You can see how the load size and distribution is represented in a fair amount of detail. On the right here, you can even see an actual picture of the modeled load. They look pretty similar. This was so successful that he was able to identify poor loading distribution to help the loader operator actually adjust their loading. These 4 examples of sensor innovations are fundamentally changing the efficiency of industrial vehicles. And this is just the beginning. At Cisco Systems, the company that I worked for, we work with the major industrial equipment manufacturers to build reliable wireless communications that get this information from vehicle sensors to operation centers, analytics tools, and asset management systems. With every new sensor innovation, the reliability of this data connection becomes even more critical. For more information on Cisco's capabilities, check out cisco.com/go/mining. For more energy and mining innovations, explore other videos on this channel. I'm Roland Plett. Take care.